All right, let's see how we can create and use pointers. So I'm going to declare an integer called number and set it to 10. Now you know that every variable has an address. If you want to print the address of number, we should prefix it with an ampersand, and this is called the address of operator. So let's print the address of number. All right, we get this hexadecimal number. Now on your machine, you're going to see a different value, so don't let that distract you. So now that we have an integer, we can declare an integer pointer by typing int asterisk. So this asterisk represents a pointer. Now, just like other variables, we're going to give this variable a name. We can call it PTR or whatever, and then initialize it to the address of number. So here we have declared an integer pointer, and this can only point to an integer variable. So if we change the type of number to something else like double, we get a compilation error saying cannot initialize a variable of type int pointer with an R value, which means right value of type double pointer. So we need to change this back to int. Now, just like other variables, if we don't initialize this pointer, it's going to hold garbage or junk values. So instead of printing the address of number, let's print our pointer. Look, the first time we run our program, we get this number. The second time, we get a different number. Now, the problem with this uninitialized pointer is that if we use it, we might end up accessing a part of memory we are not supposed to. And in that case, the operating system is going to terminate our program and say memory access violation. So as a best practice, we should always initialize our pointers. We can set this to the address of another variable, or if we don't know what variable this is going to point to, we can initialize it to null pointer or null PTR. This is a special keyword in modern C++. A null pointer is a pointer that doesn't point to anything. Now in the future, when we want to use this pointer, we can always check to see if this pointer is not a null pointer. Then we're going to use it. This is the benefit of using a null pointer. Now in the past, in the earlier versions of C++ or C, we used null, all in capital, or 0. In modern C++, we use null pointer. This is the preferred way, okay? So as a best practice, always initialize your pointers. So we're going to initialize this to the address of number. Okay, now what can we do with this pointer? Well, we have another operator called indirection or dereferencing operator. So we can type an asterisk before our pointer, and with this we can access the data at the target memory location. So if we print this, we're going to see the number 10, okay? Now, using this syntax, we can change the value at the target memory location. So we can dereference our pointer and set it to 20. Now we have changed the value at the target memory location to 20. And that means if we print number, we're going to see 20, okay? So let's quickly recap. What we have on this line is called indirection or dereferencing operator. What we have over here, the ampersand, is called the address of operator, okay? Now, one last thing before we finish this lesson. In this lesson, I've added the asterisk right after the data type, but we can also put this before our variable. The reason I don't like this approach is that it can be confused with the indirection operator. So when declaring pointers, I prefer to put the asterisk right after the type. All right, here's your exercise for this lesson. What do you think is the output of this program? So if we print the value of x and y, what are we going to see on the terminal? Without typing this, spend a minute or two and understand what exactly is happening on each line. Okay, here's the answer. So on line 6 and 7, we are declaring two integers. On line 8, we are declaring an integer pointer that is initially pointing to x. Then using dereferencing or indirection operator, we are going to that memory location where we have stored x, so we're getting that number, and then multiplying it by 2. So at this point, if we print x, x is going to be 20. Then on line 10, we are setting this pointer to the address of y. So now our pointer is pointing to a different variable. Now similarly, Using the indirectional operator, we're going to that memory location. We're getting that value, which is 20, and multiplying it by 3. So at the end of this program, x is going to be 20 and y is going to be 60.